Alright, this is lesson 93. We're going to be calculating lines of best fit and R values. So your objective today, students, will calculate lines of best fit and R values using a graphing calculator. So these calculations you will learn in statistics, but today you're not going to learn it. You're just going to learn how to do it easily on a calculator. But one day, if you take a statistics class, you're going to actually learn how to do this. But as of now, you don't need to do that. You just need to know the concept, right? And the concepts we've been working on are, we're talking about scatter plots. We all know how to do that. And then a few days ago, we learned how to put a line of best fit, kind of approximate it. And then we learned what happens when the points are exactly on the line of best fit. What kind of R value should we predict? 1 or? Good, right? Because it's very strongly correlated. What happens when the dots or points start falling off the line? It gets closer to 0. What happens when a R value is 0, everyone? Not strong, it becomes less strong, and it becomes no correlation, good, or no relationship, good. Okay? That's all we're at right now. So we already know all the concepts, so today we're actually going to learn how to use a tool, the graphing calculator, to actually take real data, and we're going to apply it, okay? And this is going to be your last little lesson before your project, because your group is going to actually pick 2 things that you're going to figure out if there's a relationship in, and then you're going to actually figure out if, how to do the data analysis with the graphing calculator, okay? So we're going to talk about that later. So if you're on the video, these are the steps. We're going to use the graphing calculator. Desmos is a good one. We're going to make a table on the calculator, and then in the calculator on Desmos, you're going to write y, and you just notice it doesn't say equals. There's this little button called a tilde, okay? Super important for Desmos. It's like an approximation. Y sub 1 tilde mx sub 1 plus b. We're going to write that as a new equation. I'm going to talk about that. We're going to adjust the scale on our calculator, and then we're going to identify the line of best fit, identify the R value, and identify the correlation between the 2 variables, okay? So, here we go. Number 1, we're going to identify the line of best fit. So this is all of my data up here. So you got all of my x's are my independent variable, and then my y are my dependent variable. So this is IVs and then DVs. Okay, this is all one big list. It looks like 3 lists because they just cut it just so it fits. And they have a graph here. So on tonight's homework, you would actually plot the points like you normally do. I'm not going to do that to save time. Okay, but how do you take this data and figure out the true line of best fit and the R value? Okay, so what you're going to do is you're going to go to Desmos. I'll show you that. How's this working? Okay, there we go. Okay. So I'm going to have my little, there it goes. That's all my data here. I'll zoom in on it so you can see it a little better on the video and on the screen. Okay, data's all here on the left, and then I got my Desmos calculator. So the first thing you want to do, we're at Desmos, second step, we're going to make a table. So we're going to press this little plus button. We're going to click on table. Okay, and we're going to start putting in all our x values. So all our x values are here on the left. Okay. So we want to plug them in. So we got 1, 3, 6, 17, 17, 19, 29, 32, 33, 41, 60, 69, 75, and 92. Okay? I did that really quick for the sake of time. But you would put that in, okay? Then we go back to the top and we want to make sure we match the y value with the x. So what number is next to 1 up here, everyone? 0.1. So we're going to put 0.1, okay? Then we're going to put the rest of them. 0.1, 0.1, 0.1, 0.2, 0.2, 0.2, 0.2, 0.3. And I want to make sure I don't go quickly because I want to be accurate. 0.4, 0.4, 0.4, 0.5. Okay? So, that wasn't quick at all. Okay. So, what do you notice about my graph? There's only like 3 points here, okay? Don't worry about that. I'm going to fix that. So, we're going to go back to the graph, and now I'm going to make a new equation. Step 3, it says write y is tilde, or it's approximate mx sub 1 plus b. So I'm going to go add item expression. It should be right here. Okay. So I'm going to put y, and then I'm going to look for the sub 1, because if I look at my table, the header of my table says x sub 1, y sub 1. These are points. So I'm going to go back to my equation here. I'm going to put y, and I have to look for that subscript button. So I click ABC, sub, and put 1, and then I'm going to click to the right, and I'm going to use the tilde button, not equals. The tilde button's right here. Okay, we're going to do MX, we're going to do that sub button, 1, plus, and then we're going to click B. Okay, and then it creates a line. Okay, so still doesn't look like anything interesting. So the next step is super important. Remember how Ms. Good talks about scale a lot on your homework and on your tests? So looking at my X is up here. What's the smallest X you see up here?
1.
1. What's the biggest one?
92.
92. So then I want my, you see how my X's only go from -10 to +10? I don't really care about negative numbers, so I'm going to go my graph settings. I'm going to go to my X axis and I'm going to type in 0 as where I want it to start, and it's going to go all the way up to 92. So I'm going to go a little bit bigger than 92. What's the next biggest number after?
93.
No, or maybe like maybe 100. How's that sound? 100, okay. And I want to use appropriate steps, so I have 100 numbers. So maybe I'll go. So I have nice numbers. I'll go by tens. Okay, that way the graph gives me a nice, or the coordinate plane gives me a nice graph. Okay. Now let's look at our y's. What's the smallest number of all my y's here? 0.1. Good. So, nope. Sorry about that. 0.1. So I'm going to go from 0. What's the largest number that's there?
0.5.
Good. So what's the next biggest number? 0.5.
1.
1. Okay. Or you could go by 0.6. But let's do 1 so it's nice and clean. And then let's do steps of, since I'm going from 0 to 1, I'm going to use a step of 1/10 here. Okay. I'm going to close that up. And now it's created a nice little graph for me that goes from 0 to 100. And it goes from 0 to 1 on the y-axis. So it's not really to scale, but at least I could see the points spread out, okay? Because really, I'm stretching the graph really wide. You see how it stretches from 0 to 100, but am I stretching it really tall?
No.
No, it goes only from 0 to 1, right? So it's kind of, we have to really imagine it to be really squished. So that means all these points are really squished. So if I'm looking at this, are there some points? So the R value here now. We're going to put, on your homework, you're going to actually put in all the points. You're going to draw the line of best fit, and then you're going to tell me what the R value is next to it. So R is equal to, we got 0.968, which is right here. Okay? Okay. Next thing I want to do is write my line of best fit, which is going to be, we know that a line, the form of a line is y equals mx plus b. So we just start with y equals, okay? M is this number here, okay? Don't worry about how to calculate it. I did it for you, so you just write it down. You get write 0.0 and go 4 decimal places for the sake of our class. 0.45. X plus b, our b is right down here, 0.0894. Okay? And that's it, okay? The next thing we want to do is step 7, analyze the correlation between the two variables. So, when I look at this R value, kids, what do you notice about our R value? Is it direct or inverse? Direct, right? Is it strong, non-significant, or is it no relationship? Strong, okay? There's a strong relationship. Okay, next question. Then we have to analyze it. As x gets bigger, what happens to y? It gets bigger, right? There's a direct relationship. As x gets bigger, what happens? Good, so then we're going to write that down also. As x gets bigger, y gets bigger. And that's number 1, okay? Makes sense? What happens as x gets smaller? What's going to happen to y? Good, it's direct, right? It's a direct relationship. Okay, so that's number 1. I'm going to show you number 2 also in a moment, so why don't we take a moment, let's pause. Okay, let's have 1 still and 2s. How did I just create a line of best fit and create these, figure out the R value and all of this information? 1s are talking, 2s are just listening right now, so I want to only hear 1s for 30 seconds. Ready, set, go. So don't write this down. Here we go. If you're on the video, just keep that handy. So here we go. Number 2. So on number 2, I'm going to move this over just a little bit. Here's some new data, okay? So I got new data. Step 1, using a graph and calculate Desmos. I'm going to make a table on step 2. Okay, so eyes up here. Let's go back to Desmos here. I'm going to clear everything out because I don't want to keep it there. Okay, and I'm going to start with, first thing I do is make a table, click on table, and start putting my data in. Can someone tell me what the x's are? First x is?
1.
Next x?
3.
No, I should just do this here. Okay, 1. Ah, I made a mistake. Start over. Okay, 1. Keep going.
3. 4.
Keep up, guys.
He's gonna figure it out.
Okay, did I get all of them? Oh, no. 9. 9. Okay, good. Got it. Okay, next one, my y's. We got 1, 3, 3, 4.
What Y's are you on?
4. Oh, thank you. See?
20,
I was just making sure
70.
you're awake. That's what I was doing. Y'all awake? Good. I'm glad. 70, 70, 70, 80. Do you see how easily you can make a mistake though?
Yeah.
Okay. But I'm glad you guys are awake. I was just doing that. I knew what I was doing. Okay. So that's step 2. Next step, step 3. We're going to write this equation down. We're going to press the plus sign here. New expression. We're going to do y sub 1. I'm going to go a little more quickly here. Is tilde mx. Oh, it's all small. I got to make sure it's on the normal size. Mx sub 1 all plus b. Okay. So now it gives me a bunch of data, and then when I look at it, I don't really have anything here. I'll press the home button to see if it helps. Oh, I only have 1 data point. So now I look at my x's. Step 4, adjust the scale on your calculator. Okay, looking at all of my x's, kids, what's the smallest x that I have up here?
1.
1. What's the biggest one? 9. So what's a number that's a little bigger than 10? Okay, what step or scale should I use? 1. Good. Excellent. Y's. What's the smallest y, everyone? 10. Good. So I'm going to go just from 0. Biggest number? 90. What's a bigger number than 90 that I could use? 100, right? What's a step I could use? Good. I like it.
Wait, so on the x-axis one, why can't you use 5 as a step?
Because then I'll just divide all of these by 5. It'll make all these by 5. It doesn't really matter. You just want it to divide it nicely. What really matters is the limits you do. These limits are the most important. The step is just how detailed the graph is, okay? Okay, so now when I look at the scale, is it drawn to scale? Is it drawn to perfect scale, or is it stretched? Did I stretch one of the axes? Yeah, I stretched it. You see? This y-axis goes up to 100, so it's like I'm taking all of these numbers and I'm squishing them all together so they fit on this graph. And then I'm taking the x-axis, 0 to 10, and I'm kind of stretching it out so it fits on this graph. Do you see that? So it should be a lot taller than it is. Okay, so looking at this, look at this line of best fit. Let's predict, are there any points on the line?
No.
No. Are the points kind of far off?
Oh, no.
Yeah, remember this graph should be stretched a lot taller than it is. It's squished together. So isn't this point way up here super far from this orange line? Yeah, definitely. So predict direct, inverse, or no relationship. Turn your neighbor. Just predict with your neighbor. What do you think it's going to be first? Remember what it is. Direct is up from left to right. Inverse is down from left to right. And then no relationship, and these are R values to be really small. So raise your hand if you say direct relationship. Raise your hand if you say inverse relationship. Raise your hand if you say no relationship. Okay, let's look at our R values. So the next thing we're going to do is you're going to go back to Desmos. You want to look at that equation it just made. Okay? So looking up here, we have our information. Let me change the color here. Okay, so, hey, look at our R value. What's our R value, everyone?
0.0398.
Okay, look at that. Marky's on his way to become a statistician.
What?
Statistician.
I said that's my chance of going to college.
Good job, Marky. He's going to become an actuary. Actuaries make a lot of money, just letting you know.
What's that?
It's someone who
It's
makes
out of my vocab.
statistical equations that measure and predict the risk for insurance companies so they make money, okay? And stay competitive too. Okay? So, next thing is our let's write the line, or equation of the line. So y is equal to what, everyone? What should I write first? What's our m?
0.3510.
0.3510 x plus
53.119.
good, okay. There's our line of best fit, okay. What do we know about our R value? Were we right? Is it direct relationship, inverse, or no relationship?
Not relationship.
No relationship, good, okay. So then we would just write a sentence, no relationship. Now we would say there is no relationship, not even a because, there is no relationship between X and Y. And you could write because. Why is there no relationship? Because of what? Why is there no relationship?
No points are on the line.
Now look at our R value. There's no relationship because our R value is
So small.
so small, close to 0, right? Y'all awake? Is this making sense? Give me a thumbs up if this makes sense. Thumbs to the sign if you're kind of lost. Thumbs down if you're just need me to start over. Okay, so. Okay, good. So most of you got it. Let's have you talk. Talking is super important. Let's have twos tell the ones. How do we do this? If you don't get it, start talking to your neighbor. Maybe they could help you. Okay, let's hear you talk. Okay, that's number 2. Ready, set, go. Okay, so number 3. Let's take out our notes. Get your Desmos ready also. Number 3. Ooh, that's nice. Look at that. Number 3. Dang.
Oh, that was beautiful.
Shh. Oh, that's number 2. Okay. It's kind of small. Let me see if I can zoom this in a bit. Okay, so number 3, can you guys and girls write this down in your notes also so that you have it? So everyone's doing just number 3. We're not talking kids in the back. I'm going to walk back there so you know that I'm there. I need you to write down number 3, the numbers. Everyone's writing down number 3.
I haven't been talking.
Okay. Everyone's writing these down. Shh. Okay, so number 3, here we go. We're going to start. Hey, we're doing this together. Please end your conversations. I want to make sure we have enough time for your group project, okay? So, first thing we want to do, we have all of the data here. We're going to do step 1, use graphing calculator like Desmos. We're going to make a table. So go to Desmos, please, and if there's anything in there, clear it out. There shouldn't be anything in there. Okay. And I'm going to clear out my table. And we're going to click the plus button. And we're going to click table. You don't want to start with an expression. So again, we're starting with Desmos, clearing everything out. Press the plus button and table, okay? Then we're going to start putting in our data. So start with your X's first. And make sure you're very careful putting everything in. I know I'm a little bit faster because I have the keyboard. Okay, those are all my X's, and I'm going to do the Y's also. The Y's, make sure you pair up correctly with the X's, otherwise it's going to be wrong. I think I did something wrong here. Oh yeah, I did something wrong. Let's try it again. 90. Start over. I made a mistake. I put 6.5. No, it's not. Okay. Sorry, I'm putting all the Y's. And make sure you got all the Y's. Now I'm catching up. Okay. So now I have all my data in. Now the next thing we're going to do is step 3. Read step 3 to your neighbor. Ready, set, go. Okay, so we're writing this equation, which just means y sub 1. So we got to find that little sub 1 button. If you press the ABC button here, I'll zoom in so you can see it better. Click the ABC button, and then there's a little A sub B button. We're clicking that. Click to the right. We're using the tilde, not the equal sign, but the tilde mx sub 1. We're all doing this with Mr. Rink. We're not just staring. This is not the Mr. Rink show. We're participating right now together. Okay? David, are you working along? Oh, you have all of it? Okay, good. All right. You're fast. Okay, now step 4. What does step 4 say, everyone? Okay, adjust the scale on your calculator. What's the smallest number in the x's, everyone? 0.8. So we'll keep the x-axis at 0. What's the largest number?
9.2.
What's the biggest number we should go up to?
10.
10. Okay, what's a good step?
1.
Good. Let's go to the y-axis. What's the smallest number?
20.
20. So let's start with 0 anyways. Go up to what number? 90 what? Okay, why don't we just go up to 100 on this one? Is that good? Okay, so looking at this, is this data drawn to scale? Is it? We change the scale. Are my x's equal to my y's? Yes or no? Is the space on the board for my x's the same as my y's? From 0 to 10 or 0 to 100, is that the same thing? No. Yes. You have a question? What? Okay, good. All right, so looking up here, we got the predict. Is it going to be a positive, direct relationship, inverse, or no relationship? What do you think? Turn your neighbor, tell your neighbor. Is it going to be direct, inverse, or no relationship? What do y'all think? Yes? I'm asking a question before we get another question. Direct, inverse, or no relationship? Everyone? Inverse. That's what we're predicting. Okay, yes, question. All right, so looking at our R value now, this gives us the data. What's our R value? R equals what? Everyone, R value is? Looking up here, what's our R value?
Negative 0.981.
Good, negative 0.981. So that's what you're going to write down in your homework. Okay, now let's write down. Is that for you now? Okay, good. Thanks. So we got y is equal to, what's our line of best fits? What's the equation for our line of best fit?
Y equals
No, y equals?
7.779.
You got to write it down. 7.779, 7, good, What do I write next? X.
X plus 96.058.
Okay, good. Got a question for y'all. Does this have a, looking at your R value, is it a direct, inverse, or no relationship? Turn to your neighbor, tell him, looking at this number right here. Is it direct, inverse, or no relationship? This isn't a trick question. You already know this. What do y'all think? Inverse. Is it strong?
Yeah.
Not significant?
Not significant.
Or is it strong, not significant, or
Not significant.
no relationship? It's strong, right? Isn't it close to -1? It's a strong inverse relationship. So let's think about this. As x gets bigger, what happens to y? Smaller. Good. So you would write that down as your sentence. Yes, question.
How did you get 96.2?
You look at b, it's supposed to be y equals mx plus b. So then m is this, you just copy that here. And B is right here. Copy that down here.
Oh.
Yeah, there's not I'm not doing any calculating. I'm just getting you to copy those down. Okay? So that's basically your lesson for today. That ends the lesson.